What I'd like to do in a few minutes is to, and some of this will be repeating some of the highlights of what you've heard, is I'd like to pull together our view of the oil outlook using a systems approach, and what the next phase we see ahead to be. And basically, it's moving into an era of price rationing of limited supplies. This is all done through the prism, as Steve mentioned, of an integrated systems approach. I began with that with very fortunate and wise teachers many decades ago, and then over the years was drawn to add another prism through which to view not only peak oil, but we've got a number of other peaking problems, all of which are serious matters because with the continuing population growth, the extraordinary first-time event in history of a quarter of the world's population, with globalization and technology rapidly developing, each a middle-class consumer, a large consumer middle class, roughly the equivalent of ours, with all of those additional demands posed on this limited Earth system that we have. So I've added in the other prism, and I urge all of you, all of us, to view all of these evolving problems through the added prism of sustainability. Unless our attempted solutions to all of these problems are sustainable, they're not going to work long term. And at the end, I'll discuss briefly proposed responses to these problems. In so doing, I will encapsulate for you our view of when peaking occurs and also the mechanism by which we work our way through this transition. Let's look at the first slide. If you can read this, this puts all of this into perspective. It's the history and future of the oil business going back to the beginning in 1870. The first 100 years I describe as the era of plenty and U.S. control. Lasted from 1870 to 1970. It all ended when we reached our all-time peak production with irreversible decline since then. And during that 100-year period, on an inflation-adjusted basis, the price averaged $13 a barrel. When our production peaked, and the exporting nations saw that, they realized they could take control in this next era, which I call the era of transition and OPEC control, and that's when the expropriations began. That lasted until roughly 2004 when they reached capacity, and during that period the price of oil, inflation adjusted, averaged $36 a barrel. And now we're in this era of scarcity and price rationing, and the key question, it's on everyone's mind these days, is what prices are going to be required in all the different types of use and all the different parts of the world to restrain consumption so that there's no growth. You can't use any more than is available. So that's the critical question for the future. If we take a look at just the more recent history from the end of World War II, 1945, to the present and our forecast out to 2015, the first thing you notice in this, this scale is 0 to 70 million barrels a day starting in 1945, is that extraordinary period of growth from 1945 to 1970. When I began work in my career in 1946, it's still a surprise to me every time I'm reminded that in the first 25 years of my career, total world oil production went from 7 million barrels a day to 47 million barrels a day. That was made possible because we had surplus producing capacity. Texas acted as a swing producer, and we controlled world oil prices by acting as a swing producer, adjusting production every month at roughly $2 a barrel for Middle East oil. You couldn't have better conditions for an unprecedented era of world economic growth and also for dominance of the world by the U.S. Limitless, cheap supplies of the finest kind of energy with the development of the tankers during World War II, cheaply deliverable all over the world, and that's the kind of growth you get. Obviously, you couldn't find enough oil to continue to support that kind of compound growth rate, 6 to 7% a year. And when that happens with any commodity, any good that's needed, prices adjust the system. Prices rose too far too fast, caused consumption to decline briefly. Then in real terms, prices actually declined for most of the world's consumers for the last half of the 70s. Consumption took off again, as you see. And then the Iranian Revolution suddenly took 6 million barrels a day out of the world market, and prices increased 2.5 times, and that had a much greater impact on consumption. Consumption fell almost 8 million barrels a day in the early part of the 80s. That's what caused the ultimate price collapse. And that left us in 1945 with 14 million barrels a day of shut-in surplus producing capacity, all of it in OPEC. And it was obvious we were going to have low prices and unfettered growth again until we used up that spare capacity. And as you can see, prices for Arab Light on the right scale, 0 to $100 a barrel, waffled around at about $15 a barrel for many years, and consumption took off again. This logical relationship between price and consumption, that continued until finally by 2004 we used up all that surplus producing capacity. Everybody at capacity, basically except the Saudis. And look at what happened to prices again. And our forecast, I'll show you a little more backup in a moment, is that this is about the peak in total petroleum production. And it's going to be followed by the kind of decline we project here in this graph for crude oil as induced by this increase in prices. And toward the end of my presentation, I'll show you in detail what we think has been happening the last year and a half or two in this actual kind of response. Now, I've been talking about crude oil. There's another 10 or 11 million barrels a day of other kinds of petroleum liquids. And this graph shows you the trends in production and the total availability going back to before the first oil crisis in 1970. The red portion at the bottom is non-OPEC other than the former Soviet Union. You can see that all of that production actually peaked many years ago, so there's no question about the peaking of that. And Eastern Europeans' crude oil production is distorted by the fact that their internal consumption collapsed and their production collapsed after the collapse of the wall. And most of this increase that they've been contributing, which is the biggest single increment of non-OPEC production supply, increase in non-OPEC production supply, was created by privatization and the Russian oil companies bringing in roughly 3,000 engineers each from Halliburton and Schlumberger, and just bringing oil production back up to the capacity curve, and we're roughly there now, so that we're forecasting this turn in total available non-OPEC production, and the yellow gap in between is OPEC production. The green band at the top is the one growing source of supply, and that's growing natural gas liquids from the aggressively expanding gas liquids business, and then the narrow orange band at the top is the synthetics, growing but relatively small in this total picture. So we project here a roughly flat total petroleum liquids supply, just over 80 million barrels a day for the next several years, and then irreversibly declining. By contrast, the blue line is still the official forecast of the U.S. Department of Energy. And that's shared also basically by the major oil companies, just sheer fiction as you see it displayed here against the trends in all of the elements of supply. This next graph shows you the response year by year to changes in oil prices that we've been experiencing. This starts with 1980. At the time of that big oil price increase following the Iranian Revolution, and the blue bars show the year-to-year percentage change in crude oil consumption. As you can see, as oil prices rose dramatically, look at the reduction in consumption year by year in response to those prices. Then prices collapsed, consumption growth took off again. It was relatively healthy for the many years of $15 oil. And then as we began to run short of oil, prices began to rise, that growth began to decline, and then there was that decline in oil prices, as you recall, in 98, 99, stimulated consumption again. And look at what's been happening to year-to-year growth in consumption since we've had this recent severe run-up in prices. It's fallen dramatically, and we had a growth of about 0.5% in the year 2005, fell to about about 0.2% last year. And as I'll show you in a little more detail later, we think that there actually has been a small reduction in total oil consumption this year. That's quite contrary to all of the numbers that are still being put out by the IEA principally, and then parroted by everyone else. In terms of the different regions' response to these various price changes, this shows the history going back to 1973. It's divided by the principal OECD countries at the bottom, the developed world. The red line at the bottom is Japan, Canada, Australia, New Zealand. The green line is Western Europe. The purple line is the United States. And the most striking thing you see there is that in all of the developed countries, in response to those big increases in prices, we've had a permanent change in our degree of and intensity of oil usage. In fact, it took almost 25 years to reach the peak oil consumption we'd had previously in 1979. And some of those regions are still not back there yet. The bulk of the growth took place in the developing world. The red line you see above that. And with the forecast decline that I've been talking about, peaking of petroleum, this is how we see that distributed response of growth to price. Now, in the next several years, the manner in which this adjustment occurs is shown here in examining the relative types and values of use, excuse me, in the world total as compared to the United States on the right. In the highly developed countries like the U.S., as you see on the right, almost 70% of all the oil we use is for transportation, another 7% for residential and commercial, about 10% for raw material, or about 90% for hard-to-substitute, relatively high-value uses. On a worldwide basis, it's closer to a little over 50% for transportation. And then the green bar you see at the bottom, about a little over 20 million barrels a day, is oil burned in stationary fuel use, where all you want is the BTU. And at these kinds of oil prices, $10 to $12 per million BTU for that fuel oil, they're going to be much more efficient use responses, and there will be substitution of cheaper fuels, and that fuel oil will be converted to transportation fuel in additional refinery processing facilities to accommodate the continuing growth in that high-value premium use that you've heard a lot about during this meeting for transportation fuel. One of the reasons that we haven't seen more response than we've seen, although I'm showing you this is beginning, is the fact that the world is so much wealthier now. Just greatly increased rates of wealth generation, and we use oil a lot more efficiently. So I just show the illustration here. At $60 a barrel today, we're only spending 3.5% of our GDP to buy our oil on a worldwide basis. In the previous two crises, we were spending twice that much, 7% of GDP. So it takes a higher oil price this time around to produce the same consumption response that we saw in the first two crises. In winding up, what I'd like to do is to describe to you the manner in which we think this whole system operates in this environment. And that is the only oil producer, the principal oil exporter, that has any unused producing capacity and has the dominant resource potential to expand their production to create a cushion is Saudi Arabia. They made the decision many years ago with much careful study that a rational long-term business plan for the kingdom would be to plan on producing 8 to 10 million barrels a day of oil, because that was something they could confidently do for the next several decades, recognizing that as their big old fields decline, they're having to replace that production with a lot more investment per barrel, a lot more technology, a lot more infrastructure and people, and basically that's the path they've been on. This is a history going back to the early 70s of the annual production in millions of barrels a day. The scale is 0 to 12 million barrels a day in Saudi Arabia, and it varies generally in that band of 8 to 10 million barrels a day. Except for that experience in the early 80s, which is indelibly embedded in their minds, of having held on to contract price, high prices, much too long, and losing much of their business to the other exporting countries. They made a determined drive then to get back up to this level. They've been there now for the last 13 or 14 years, and they're in a position to exercise the kind of control of world oil prices that the Texas Railroad Commission exercised so effectively for 40 years, and that is assume everybody else is going to produce at capacity and adjust your production monthly. Nobody's able to get good enough information or accurately forecast usage enough into the future to do it on more than a monthly basis, because you can always adjust for any mistake that you made. They've been to Austin many times to study that. And we thought that at this point they would be managing this better with less volatility of prices. But the problem, as we've identified it, is they're confused by the numbers. And we think that that's the primary factor affecting high oil prices that we have today. My last exhibit here is this table, and this shows a breakdown of consumption and supply from the various sources in 2005, 2006, and our estimate for this year. At the top, total consumption is shown, and that has varied very little because of this increase in prices. We estimated at 80.4 million barrels a day in 2005, 80.7 in 2006, a slight decline this year, 80.5. And the error the Saudis made was that the IEA forecast last fall that we're going to see the largest increase in non-OPEC production this year since 1984, 1.8 million barrels a day. And in fear of that, OPEC, and led primarily by Saudi Arabia, cut back their production, their quota, 1.7 million barrels a day, and their actual production, 1.2 million barrels a day at the beginning of the year. And as it's turned out, there's been very little increase in non-OPEC supply, and therefore we have constrained supply-demand balances. We've got a shortage of oil, and because of this mistaken action by Saudi Arabia, We estimate we've actually had continuous inventory draws for 2 years in a row now, and that inevitably results in the kind of increase in prices that we've been experiencing. Everything you read indicates that this is because of demand pressures. No one ever mentions that it's because of a mistaken move by Saudi Arabia, who reduced supply at a time that we needed. They've begun trying to redress this, increase production about 200,000 barrels a day the 1st of November. They'll probably take more action in December, and then we think that quite a bit of this price pressure will be taken off. Now, as this kind of picture unfolds in the future, how can and should we respond to this? As Steve mentioned, I've spent the last 3 years working with some very good people, also on the board of the College of Engineering. And as you think about this kind of problem, and we need to apply this kind of approach to all of the other peak problems that we're facing in the world: peak population, peak clean water, peak clean air, peak metals from the Earth's crust, peak food, and that is, what you must do is first do a very, very objective, without any ideology, analysis of the problem. What is the problem? What are its elements? We've had a lot of that going on at this meeting. You need that in order to identify, as has been done at this meeting, the areas where we need additional good science, research and good science to find out if there are technical solutions to these problems and what they are. And only after you've done those two are you in a position then to project policy, sound policy, and start trying to put it into widespread use. In winding up, and this has been mentioned by other speakers, the great barrier to doing this in all of these areas is that in our system, and this is spreading throughout the rest of the world, as has been mentioned by other speakers, it's impossible to get anybody to do something today because there's going to be a problem tomorrow. I worked on energy policy in Washington in the 70s, and that's the most important thing that I learned. It's worse today because the elected officials have to raise larger amounts of money, and in this environment, no one is going to vote for any of these new policies until their voter constituents are suffering tremendous pain and inconvenience and hardship, have gotten together in groups like this and in local groups and come up with what they think should be done, and then propose that to their congressman, we want you to vote on this. Then it'll be safe enough to do it. So we're not likely to see any real response to this, and not very much is going to happen until we hit the brick wall and then begin this sort of thing. And what we hope to do at this Energy Institute at the University of Texas is be ready when that happens, so that generally the response is to go many, many directions at once, most wrong, most wasteful, and we hope to have a rational approach to this, and we need more institutes like this throughout the world. We think Austin is a place to have the premier institute, more depth and breadth of expertise in all aspects of energy there and any other place in the world. We're bringing in the Russians, the Chinese. This is a global problem, have all of their cooperation in this. So this is the way we see this problem unfolding and the response to the problem. Thank you very much. I've run over my time a little. I appreciate your time.